So hello everyone, my name is Rob Davis. I'm a research engineer at the Centre, and I'm here to talk to you just very briefly today about ML interpretability, something that we've mentioned a few times in the session today. Okay, there are some incredible ML methods that have been developed both here at the Centre and more broadly in the ML community, and they can do amazing things. However, these methods are limited, have a limited impact without interpretability methods running alongside them, particularly in a high-stakes environment such as medicine, where you need to have utmost confidence in a given prediction. Yeah, a black box model just isn't good enough anymore because it is such a high-stakes environment. There are also many different types of model. We talked a lot about time series, but the traditional ML interpretability methods are just simple post hoc explanations of static predictions. Again, that isn't enough anymore. We need multiple different methods to sort of span the full range of our different ML methods. So we need interpretability methods for time series, for patient trajectories. We need unsupervised learning methods for patient phenotyping. We need to interpret heterogeneous effects estimations for personalized therapeutics, and we need concept-based explainers to discover new clinical concepts. At CCAIM, we're developing a suite of different interpretability methods. The images on the screen are from our interpretability GitHub, that aims to gather together all of our methods alongside some key methods from the community and explain when you should use each method, help you understand them and implement them. As I say, we've got many different methods and many different interpretability methods for those, so we need to cover. These are all examples of tabular data explainers. We also have time series and unsupervised methods, and recently a new interpretability method for individualized treatment effects. Each interpretability method works in a different way to provide a different type of explanation that broadly breaks down into feature-based explanations, which are those that indicate the input features that were important to that individual prediction. We also have case-based explanations, that is methods that show you examples that the model sees as being similar to the input record, so you can compare and contrast that way. And we also have concept-based explainers, so that this is any method where, well, these are methods where you can provide concepts to the model and then see how important that concept was to the model's prediction. And so, yeah, by going through those, I hope you can see we have methods that are both generic, that they work across the board, and also personalizable, and by which I mean personalizable to the user, not just to the patient. So yeah, that's things like the concept-based explainer there, but there are others as well where you're providing your own context and then you see back an explanation in those terms. And so yeah, this is just a quick talk, and I'd like to end on three things. The first is, if you follow the first link here, that will take you to one of my favorite methods from the suite, which is Simplex. And there you can see it used in action in a demonstrator app. Just like the screenshots that Evgeny showed you, there's another demonstrator we have. So yeah, I'd encourage you to follow that link if you're interested. Second is the Interpretability Suite on GitHub. So those are the images I showed you, but there's a full breakdown of all of our methods with lots of information if you want to read about the different methods that we have. And finally, I'd like to say, just watch this space. There's lots happening in this area, and I hope to speak to you at a future clinic with much more detail on all of these different methods, and hopefully show you some more user interfaces like the demonstrator linked here.